We're going to continue on with our instruction in traversing, and this is Survey 1315, Survey Mathematics at Odessa College, and we have an exercise to do. You've already seen the figure, and I would suggest doing a screenshot on the introduction because you've got everything you need for the exercise. What we're going to do is traverse. This is a field traverse, which we're going to use to then, in our next setup, use these points. Once you have your traverse nice and tight, you're going to do some side shots, and I'll show you how to do that. And then you're going to establish the coordinates for your boundary, which is outside of the traverse, and then you're going to inverse between all of the points on the boundary on the next exercise and determine, is it like the boundary described in the deed. Anyway, this exercise, what we're going to do is take a traverse where we backside on A, and all a backside is just a handy reference point. You shoot a distance, preferably. In this case, it's 80 feet exactly, 80.00. Looking back at this point, occupying this point for the purpose of turning an angle to get onto the next traverse point, which is placed where you can see the point over here. And you've got this point here to see this point here, and this point here to see that point there, and that point there to see that point there. So anyway, you've got this reference point, and you assign it due east because that's the bearing of the line that you're following out here, and you just call it north 90 degrees east. That's simple. It's due east, 80 feet. Set up there, turn this angle 78 degrees 41 minutes 14 seconds. It's an angle right, and then go 50.99 feet, otherwise known as 60 feet, but I'm going to be precise about that. So anyway, 50.99, and then go to point C. After you get to point C, you set a nail there, or some means of finding it. You've got a nail here, and you set a backside here, or have your rodman walk back or stay here, whatever. That'll be your new backside point, that'll be your occupied point. So you already know the distance there, and what you do is you go from 90 degrees due east, do a bearing intersection, or you take the angle and form the bearing. Give me the bearing of that, because you'll get bearing and distance. So you're starting at 100x 100y. You go 90 feet due east, well, you know that it's 80 feet plus on the x and 0 on the y. That gives you your x and y coordinates for point B. Now you have to do a true calculation where you turn an angle from due east, 78.4114, and go 50.99, and give me the coordinates for this point. Then you occupy this point in real life, backside that point, and from this bearing that you know, you then go 91, 50, 41 angle right, 60.83 feet. So once you have the coordinates for that point, you turn that angle, get the bearing, and then go 60.83 feet. Using sine, cosine, and tangent, etc., you give me the coordinates for point D. And once you do that, then you set up here, backside here, use this bearing, turn an angle of 113.2945, go 41.23, and ideally, by doing that, you end up with the same coordinates, 100, 100, that you started with. Now I will let you in on a little secret. The angles don't add up. So that's the first thing you do when you come up with a traverse. Do the angles add up to the correct number of degrees? And our formula is n minus 2 times 180 equals the number of degrees that figure ought to have. in which case it's 360. So if you come up short, get the figure, divide by 4 because you got 4 angles, add them. If you come up long, subtract and get down to exactly 360 degrees. It's the very first thing you do in your traverse, balance the angles. After you do that, then you can go from point to point, establishing coordinates. So first you close the angles, then you calculate the bearings from, you know A to B, north 90 degrees east. Calculate the bearing B to C, and then calculate the bearing C to D, calculate the bearing B to A. Because you've got angles, then you've got to establish your coordinates for C and D. And then, because you have all this time hanging on your hands, I want you to calculate the area, as we did in the previous exercise. So calculate the bearing and the distance from B to D and from A to C, and then give me the distance. Here's the formula: AC times BD times the sine of the intersecting angle, and as we demonstrated the last time, it doesn't matter which of these angles you use because the sine of an angle is equal to the sine of its complement. So all that, AC times BD times sine theta over 2 will give you the area. So go ahead and do that, and then after you get me good figures on that, we'll come back and finish the rest of the exercise.